All right, today we're going to talk about greatest common factor and difference of perfect squares. So what's important to remember is for your greatest common factor, GCF, it's a factor of all the terms have in common. So when you factor, it's basically the reverse of multiplying. So when you factor things, you're going to be dividing it out. So step one, find the greatest common factor. That's going to go outside the parentheses. Step two, write the terms after dividing by your GCF inside. So basically the leftovers go inside the parentheses. And then step three, make sure that you have completely factored everything. So let's go ahead, let's get started with number one. So we want to think about what factor or that they have in common. So in this case, they both have 3. So because this is 3 times 1. And then this is 3 times 2 times 1 times 6 are all the factors. So let's go ahead and then let's write this out. So I can divide each term by 3. And then if I were to divide 3 by 3, I get a 1. And then if I were to divide this 6 by 3, you get a 2. But we're not done, because if you were to look here, notice that you also have variables in common. So they both have an x in common. And if you were to take x squared divided by x, you have 1 left over. And if you were to take x divided by x, you get 1, so that's left over. So then just rewrite it, and then that's factored. All right, so let's look at number 2. So for number 2, we're going to look at just the numbers. We have 4, 8, and -4. They all have 4 in common. Now let's go ahead and let's look at the variables. Well, I have an x squared here and x here. Well, I don't have an x here, so we can't use x. So we don't have to worry about that one. So now divide everything by 4, and you're going to have x squared plus 2x minus 2. Or excuse me, minus 1. Sorry. All right, and then that's it. All right, this one is a challenge. You're going to do this one, but I'm going to give you a hint. You are going to have a 5. You are going to have an x you're going to have a number, you will have an x, and you will have a y. So go ahead, I want you to complete this one. All right, now let's look at difference of 2 squares. So when you're doing the difference of 2 squares, you're basically subtracting 2 perfect squares. So that's your 1 times 1, 2 times 2, 3 times 3, so on and so forth. So your 1 squared, 2 squared, 3 squared. So they need to be perfect squares. Variable perfect squares would have exponents of, they're even. So x squared, x to the 4th, x to the 6th, because if they're a pair, you can take one of them out. All right, so first step, always check for greatest common factor. So let's look at number 1. Well, we don't have any numbers in common, and they don't have any variables in common, so we're good there. Then it says check to see if both terms are perfect squares. So let's look. Is this a perfect square? Yes, because you've got x squared. Is 81 a perfect square? Yes, because it's 9 times 9. So now what you're going to do is you go x plus 9, and then to get this negative right here, one has to be positive, the other has to be negative. All right, so now let's go ahead and let's just check it. So this is factored, so if we were to check this, you distribute to here, x squared, and then you distribute to here, minus 9x. Then you go ahead and you distribute here. Oops, that's really bad. And then distribute here. All right, so now when you notice, these two terms will cancel each other out. They become 0. And so you get x squared minus 81, which is what we started with. So you know you did it correctly. All right, you don't have to check all your answers, but if you're not sure, it's always best to check. All right, so let's go ahead and let's do number 2. So right now, there's no greatest common factor, but let's look. Is 4 a perfect square? Yes. Is this a perfect square? Yes. And is 9 a perfect square? Yes. So we can do difference of squares. So we're going to make this 2x, and again, it doesn't matter which one comes first, plus 3, because the square root of 9 is 3. And then we're going to go 2x minus 3. And again, remember, one needs to be plus, the other needs to be 9 or a minus, because your terms in the middle should cancel each other out. And then they're good to go there. So let's look at number 4. You're going to do that one. Let's look at number 4 real quick. Notice this negative right here. That negative is kind of throwing things off. So when you have this negative, what you're going to do is you're actually going to factor out, and I'll write this in black. All right, because it's out front and it's not with both of them. So let's go ahead and let's factor out a negative 1. So then you're going to have x squared minus 49. Now that you've got x squared minus 49, let's look. Perfect square, perfect square. Now we can factor. So we've got x and 7, and it doesn't matter which one comes first, plus or minus. But do need to have one is plus and the other is negative. And then again, you can multiply all those to check. All right. For number 5, it looks like you're supposed to have, I want you to go ahead and write this. If it's not on your, write the 8 in there. I think that was a typo, so you're supposed to have that. So let's go ahead, let's do number 5. So let's factor out GCF. So to factor out, we're going to do 2. And you're left over with 4 squared minus 9. All right, so now let's check. Perfect square, perfect square, perfect square. So let's go ahead and factor. 2, and then the square root of 4 is 2, and the square root of x squared is x, and then the square root of 9 is 3. And then we basically copy the same thing over here, but you need to make sure you have one as a plus and the other is a minus, so your terms cancel out. All right, so you're going to go ahead and you're going to do these 3 right here. You're going to complete those. Just be careful with 8, because you actually have 2 variables. They're different, but each of them are perfect squares. All right, and I want you to write this on the bottom for your special note. I've said before you need to have 1 plus and 1 minus, and that's because you need a negative. So if you have a plus, this does not factor and it's prime, because if you get, the only way to get addition sign is they both need to be positive or they both need to be negative. So if you're, both fractions would be the same. So if you were to come down here and multiply, you get a squared. Those together would add to 2b, and then b times b is b squared. So here you have this term in the middle because these are both pluses. So one of your terms did not cancel out. Here, notice these are both negative. So if you're to distribute, you get a squared, and then here you get negative ab and negative ab, which gives you negative 2ab. And then negative b times negative b gives you positive b squared. So again, notice that it has that term in the middle. So the plus, if you have a plus sign in the middle, you cannot factor it. So you can't multiply to get a squared plus b squared. So make sure you write that down. So remember, you need to get greatest common factor factored out. And then once you divide each of the terms, anything left over stays inside the parentheses. And then for difference of squares, you need to have 2 perfect squares. Factor the greatest common factor first, and then go ahead and check perfect squares. But remember, one needs to be a positive, one needs to be a negative. So if you have that, you can factor.